let's uh, conclude the finally postulates part. So we will just conclude it, and if time allows, we will just try to do the problem. And obviously, don't worry about the problem. In every day, we will use these postulates. We will use these postulates, and we will again revise this thing again and again. So we are just going to the final level of that understanding that postulates of quantum mechanics. In last class, we have just deal about the postulates 5, and it will tell you about the time evolution of quantum mechanical state. And for that, what we need the Hamiltonian operator. And once you need the Hamiltonian operator, you can find the energy eigenvalue. And once you find the energy eigenvalue, then you can easily talk about the time evolution. So, and yes, in the last class, what we have seen the state is going to change, the direction is going to change, but basis vector will remain same. What is going to change? We will find a new vector. And it's some kind of rotation if you try to understand in a very simple language that yes, a state is going to rotate with the time, but yes, magnitude is going to same. So let's start from there. So today first thing is that we are going to explain time evolution of probability density, and then we will just deal it what we are doing actually. So let's come to this particular postulate 5. So we have from postulate 5 that h phi n is equal to basically En phi n, and we have H phi m is equal to Em phi m. And what we have, this is at something stationary state, you can tell it. And at t is equal to 0, at t is equal to 0, what we have, let's say Cn phi n plus Cm phi m. And yes, it's a very convenient that we can find this state as orthonormal. This energy eigenstate is orthonormal in nature. And yes, what will happen after time t? We can easily write this whole expression that psi t is actually Cn e to the power minus I En t upon h cut. And yes, this is phi n plus Cm e to the power minus I Em t upon h cut phi m. And you can easily find that psi t at 0, at t at 0 will nothing but actually mod Cn square plus mod C square. In the last class we have done it. And similarly, we can also find psi at t is equal to t, at t is equal to t is also mod Cn square plus mod Cm square. We have done it. Now my question is that what will happen to mod psi square? Mod psi square at t is equal to 0, and what will happen at mod psi t after time t? So obviously we have discussed earlier, whenever we are talking about the probability density, and this is all about the expression of probability density, and we assume that my psi is normalized, so I can claim this value is 1 because I have to use it as a probability density. So why I can claim this value is 1. If this value is not 1, don't worry, I can divide it with the norms, I can make it norm. So this is just a mathematical practice that you can make any vector to make it normalized. So now the question is that how you can write mod psi square. And for that purpose, we have to use the functional form. You remember in the last class, earlier we have discussed it. So let's try to write what will happen at psi t is equal to 0. So I can start with the beginning. So what I can write, I can just remove this part because this is not needed right now. So just a minute. Sorry. So what will happen at psi t is equal to 0 is equal to Cn phi n plus Cm phi m. I can write it in the form of functional form. So what will be psi star? So psi star t is equal to 0 is nothing but Cn star phi n star plus Cm star phi m star. What will be mod psi square? The mod psi square is nothing but psi star psi. And when we can that go for the multiplication of the all this thing, please mute yourself. Then you can have 4 term. The first term is this in this. So you have mod Cn square, mod phi n square plus mod Cm square, mod phi m square plus you have cross term. You can write this thing as Cn star Cm phi n star phi m plus again you have cross term, and this time you can write Cm star Cn phi m star phi m. Now this is actually the expression of mod psi square. Now we can write this whole thing. This is I can say this is the conjugate of this particular function. Just convince yourself. If this is function u, then this function is u star, isn't it? So what will happen? You can suppose you have two complex function u plus u star is nothing but the real part of u, 2 times real part of u. You remember from the complex variable. So what I can write this thing as mod Cn square, mod phi n square plus mod Cm square, mod phi m square plus 2 times real part of Cn star Cm phi n star phi m, isn't it? So look at, you have something very interesting. You are getting something very interesting. Now we are finding it at time t is equal to 0. At time t is equal to 0. What will happen to this particular mod psi square after time t? This is our challenge. So obviously we have to use this one. We have to use this one. So let's try to figure it out. What will happen mod psi t square? Then we can compare it. What is going to change? So let's try to go for it. Up to that, if you have any doubt, you can just ask me. Okay, so let's go for a next level of calculation. So what you have psi t as Cn e to the power minus I En t upon h cut, and this is your phi n plus Cm e to the power minus I Em t upon h cut. This is your phi m. And If you want to write psi star t, then psi star t is Cn star. This I will convert it to minus I, minus plus. So this will be e to the power I En t upon h cut phi n star plus Cm star e to the power I Em t upon h cut phi m star. And now we can again going to find out what will be mod psi t square. And when we are going to calculate this mod psi t square, then we have again cross term. These and these are going to cancel out. So what you have mod cn square, mod phi n square, mod cm square, mod phi m square. But when you are going for the cross term, it's a very interesting. The time part will come in picture. And what will you get? You will get mod cn square. Sorry, this will be something cn star cm, and you have phi n star phi m e to the power, here is I ent, here is minus I, and then I can write e to the power I t upon h cut. I can write en minus em. Okay, so this is the first term. The calculation is a little bit lengthy, but it's straightforward. There is not any problem. So next we will just go for these and these. So you have basically the next part is cm star cm, cm star cn, then phi m star phi n, and now this will be plus and this will be minus. So I can take minus sign outside. So I can write e to the power minus I t upon h cut en minus em. So now again you have this part is okay. These are the real quantity. Again you can check if this is some function u, this function is star. You can just check it. Make sure cn star to the star is cn, cm star is cm, phi n star to star is phi n, phi m star is phi m. Here I will convert it to minus I. So this will be again the same thing. So what will happen? I can write in some different colors such that you can. This is mod cn square, mod phi n square, mod cm square, mod phi m square, and 2 time real part of, I am writing it here, okay, 2 time real part of cn star cm phi n star phi m. And what will be real part of this particular function? Cos.
Costs.
Cos function. So you have cos en minus em t upon h cut. So what will happen? This is at t is equal to 0, and this yellow color writing, you can just take something like this, okay, because I have not any space here. So I have make this as from different color. You can just find what is going to change. First of all, have you seen this type of expression ever before that? Anyone? Can you see this type of expression ever? Have you seen this type of expression? It's a very popular, the form is very popular.
Young double slit experiment.
Yes, you have seen this type of expression for the superposition of wave. And this is nothing but the amplitude square, A1 square. So what is, you can get the total intensity is all about mod A1 square plus mod A2 square plus 2 time A1, A2 and cos of delta. And this cos of delta is here dependent on time. This is just going to change with the time, and this is going to periodically changing with the time. periodically, because cos function is periodic function of the 2 pi. So what is going to happen? So this is nothing but the probability density. This is expression of probability density. The probability density is itself going to changing with the time. And look at, this is for the single particle. I am not talking about 2 particle and 3 particle. So this is the same thing. So what is going to happen? There is interference pattern, something like interference pattern between superposition of 2 state. And that 2 state is basically energy eigenstate. And they will give you exactly same interference pattern, something like you have seen in the light. And yes, here we can justify that all superposition between a state can be possible for the single particle. And yes, what is going to happen? After what time it will again come to its original state? Sorry, original probability density? After what time? When this number, this cos number is going to 1. So it will again become, so what will happen? Psi 0 mod square is equal to psi t square. Then what will happen? This implies this number, that cos En minus Em t upon h cut must be equal to 1. And it must be equal to 1. What is meaning of that? Meaning of that, you can find that En minus Em upon h cut into t must be equal to 2 pi, integral multiple of 2 pi. And this is the minimum time. This is the minimum time in which the particle will again come into original probability density. This is the minimum time that particle will again come into its original probability density. We can find the time here. And what will be value of time? If you will allow me, I don't want to delete any part. So I can write this time is actually 2 pi h cut upon En minus Em. And this is actually identified as minimum uncertainty. This is actually identified as minimum uncertainty. So what will happen? The particle will always try to, according to postulates 2, the particle will have any of the energy eigenvalue can be its energy can be at its measurement. So what will happen? According to postulates 4, if we are getting some energy eigenvalue En, that time my particle will be in the state phi n. And if in the second measurement, if I am getting the state Em, then particle is going to next state phi m. So what will happen? The particle is continuously changing their state, and how frequently they are changing their state will depends on what will be probability to find the particle in that particular state. And due to this always transition between the state for the particle, we have the minimum error, and that minimum time error or minimum time is this much. So you have this all about, you cannot find that particle will be stuck in some particular state. So if we have superposition of a state, then it can go from En to Em, Em to En at, suppose this Cn and Cm is 4 and 3, then out of 4 time it will, sorry, some 4 and 3, then you can find what will be probability that it will remain in the phi n, and what will be probability it will remain at the phi m. So this is all about this particular postulates or postulates 5. So whenever the time involved, then you have to calculate the energy. And so why energy and time are very much symmetric to each other. You know that energy is symmetric in a time. In a time space, energy is symmetric. And if you want to calculate, so why there is uncertainty principle between delta E into delta T, because both are basically something conjugate type of variables to each other. So it's a very interesting thing that you can find. And now if we are going to discuss different type of problem, then it will become more and more clear. But everything I have done from the postulates point of view. If you have any doubt, you can just ask me. So postulates 5 will tell you all about probability density, all about and time evolution of a state as well as time evolution of probability density. So this is a very strong postulates. And so why Schrodinger wave equation have so much value into this particular quantum mechanics, such as Newton's law has so much value into the classical mechanics. In classical mechanics, from the Newton's law, you can find how your x and p is evolving with the time, and here you can find how your psi is evolving with the time, and you can justify each and everything what we have started. That particle is, yes, behaving like a wave, yes, they can same time they can behaving like a particle, yes, their measurement is probabilistic, yes, everything what is observed can be explained by application of these 5 postulates. So this is all about your 5 postulates of quantum mechanics. So
Sir,
if you have any doubt, yes.
sir, you said that the particle is not stuck in a state and it is keep on going back
No,
and forth.
if this is state, if this is
Shite.
state,
Yes.
psi t,
Yes.
okay, so suppose this is state,
Yes, sir.
okay,
So it's going
psi
from
is
shite.
state, psi
Okay.
n to psi m, phi m to phi n, it is continuously changing. What is meaning of getting probability associated to the en? Suppose probability is 3 upon 4 to getting
Yes, sir.
the en. What is meaning of that? Meaning of that, out of 4 time, 3 time it is in phi n, and 1 time it is in phi m. Suppose this state is superposition with 2 eigenstate. So this is a very simple thing. Otherwise, you have n number of superposition, and it is very complicated situation. It is very complicated situation. But for the ideal condition, suppose my state is superimposed with 2 eigenstate, 2 energy eigenstate. What will happen? There is probability associated with this. You cannot say that you will always find particle at the phi n, or you will always find particle at the phi m. What you can say? You can say there is a chance of getting the particle in a phi n, and there is a chance of getting the particle in a phi m. The weight factor is associated. So these are the weight factor. Probability, weight is probability, that a fraction. You can say that out of 4 time, 3 time it will remain in the ground state, and 1 time it will remain in the first excited state for any particular state psi. Means the particle is changing its energy eigenstate, isn't it?
Sir, yes, and it is making this change in the time delta t. After
No,
every
in the delta t time it will again come to its original state, in the same state.
and then again after delta t, it
Again, again,
goes to.
again, 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 it will going to change.
Okay. Sir.
Means there is some cyclic event is going on.
Yes, sir. Yes. Okay. Sir.
Okay, there is some cyclic event is going on, and every this time, and every time it will going to its original state. Means you are just seeing it, its original state means that will be come into the same state. Okay, same probability distribution. Means originally where you have seen, you will find particle again. So this is the error. This is the error in time, isn't it?
Yes, sir.
Okay, so let me discuss 1 or 2 problem, and that will clear all the concept. So now we will discuss next 30 minutes with different types of problems, and everything we will discuss very nicely. Okay, so let's go for straightforward problems. And yes, now we will use postulates 1, 2, 3, 4, everything together. Don't worry. So let us start with some problem on postulates 1, then we will use 2, 3, 4, and then we will go for 4 and 5. So everything we will discuss. Now let's go for this. Let's say psi x is a state of a system which is defined as, let's say, A, where x is between 0 to A and 0 otherwise. So first question, what will be probability to find the particle between 0 to A by 2. Second, find expectation value of x. So we have to just calculate this thing. If you want, we can find expected x square. I am just giving the primitive question. Okay. So obviously this is the psi x. So obviously this is psi x. You can just talk about probability density. So what will be mod psi square? The mod psi square is equal to mod a square. And this is the probability density. But you have to always normalize it. So you can find mod psi square dx must be equal to 1, and this is between minus infinity to plus infinity. Then only it will behave like a probability density. So you can just write this particular integration. So this will be defined only for 0 to A, otherwise it is 0. So you have 0 to A mod A square dx is equal to 1. So A is equal to 1 by root A. So this is your wave function, don't worry. This is a wave function. Your psi, if you are going to plot psi x versus x, so this will be something like this. So this is a wave function. And this number is 1 upon root A. So this is the wave function. Now, you just want to calculate what will be probability. So what will be probability such that x is between 0 to A by 2. So you can find 0 to A by 2 mod psi square dx upon minus infinity to plus infinity mod psi square dx. So you can just find this thing. Obviously, I have calculated this value is 1. If I will put A is equal to 1 by root 2, so there is no need to calculate this thing. I can directly write this one. So this will be, you can find 1 upon A mod psi square is A, 0 to A by 2 dx, and denominator you have 1. So this will be half. So there is 50% chance that particle will be between 0 to A by 2. So there is 50% chance that particle will be between 0 to A by 2. Okay. So this is very, very simple stuff. So if you have any doubt, you can just ask me. Then I will go for second question. So now we have to calculate what will be expectation value of x. So what is expectation value of x? You can find the expectation value of x is something. So this is expectation value of x. You will just go for psi and psi, isn't it? We have told you earlier, any operator A, then expectation value of this. So you can, this is the continuous function. This is continuous function. So what you can go? You can just go for minus infinity to plus infinity psi star x psi dx upon minus infinity to plus infinity psi star psi dx. Please, this is very important for the examination point of view, because sometime the people will not give you a and something, so you will just miss the normalization part. So even if you will miss the normalization part, if you are going to use this formula, then you can always get the correct answer. So it is very important. Okay, so you can just go for calculating all this thing. So obviously minus infinity to plus infinity, but you have to integrate between 0 to a. 0 to a. I have calculated the value of a is 1 by root a. X will operate on this, will give you x, and this is psi x is nothing but 1 by root dx, and inside 0 to a you can calculate 1 by root a, 1 by root a. So what will be this particular value? So 1 by root a, 1 by root a, sorry, 1 by root a, 1 by root a dx. So this value is 1, don't worry. So you have 1 by a integration 0 a x dx by 1. So you are fortunate that I am getting this thing. Otherwise, you can find sometime you will do the blunder. I will give into the test, don't worry. So when you are going to calculate it, this value is equal to a by 2. So what is average value of x? The average value of x is a by 2. So someone will ask you on an average, where is the particle? Someone will ask you on an average, where is a particle? You are saying that particle have finite probability to find between 0 to a, but on an average, where is particle? Then on an average, the particle is basically at the center a by 2. You can get the particle is at some point a by 2 on an average. So this will reveal something classical approach of a particle. If you are calculating delta x, then it will just tell you something like classically particle will be at the a by 2. But actually particle will be between 0 to a at any point. And you can find the probability that what will be probability that it will at the center and at some places. You can easily find. So if you have any doubt, you can just ask me. Okay, so let's go for next problem. So this is a complete problem for postulates 1. You can have psi, you can find each and everything, and you can just discuss this thing. Okay. Okay. So postulates 1 have basically main reason to get what will be probability density, and this probability density is only talk about what is the probability that particle will be found at some point. So this is nothing to do with the postulates 2, because that there is also probability is involved. That will tell you about the measurement of a state. The first postulates will just tell you what will be the probability that particle will be at this point or this point or this point. Okay, so let's go for postulates. So next we will go for problems based on postulates 2. So there is a operator A, and that operator is basically a naught 0 0 0 a naught 0 0 0 to a naught. So I have deliberately taken the degenerate state. If A will measured on state psi, and psi is defined, let's say 1 2 3. If A will measured on a state psi, what will measurement? and what probability? So this is the story. So obviously you have to find the eigenvalue. So what is eigenvalue? So let's say A1 is equal to A naught, A2 is equal to again A naught, A3 is equal to 2A naught. And for the A1, you have to find the eigenvectors, and that will be identified as eigenstate. You can easily find their diagonal matrix. So phi 1 will be 1 0 0, phi 2 will be 0 1 0, and phi 3 will be 0 0 1. You can easily calculate for the diagonal matrix. You can easily calculate. I am just writing directly because I know if the thing is diagonal, then if matrix is diagonal, then you have eigenvector 1 0 0 0 1 0 0 0 1. It's a very trivial. Now, what will be probability of getting A naught? So probability of getting A naught, there are two states are involved. From this state, there is also A naught. From this state, there is also A naught. So what you will do? The probability of getting A naught is phi 1 psi mod psi square psi and psi plus phi 2 psi mod psi square psi or psi. Now you can ask this question again. When you will get A naught? You will get A naught either from phi 1 or phi 2. So look at, you are getting A naught either from measurement of phi 1 or measurement of phi 2. And in the probability, if you are using OR, then you will sum it. Simple. If you are using OR, then you can sum it. So obviously, you can just add it, these two things. So what is phi 1? 1 0 0. And this value is equal to, let's say, 1 2 3 mod square. And there is psi is 1 square, 2 square, 3 square, plus you have 0 1 0, 1 2 3 mod square, you have 1 square plus 2 square plus 3 square. And now you can easily calculate this whole stuff. And so probability of getting A naught is all about 1 plus 1 4 plus 9, that is 1 upon 14 plus plus second term is also there. So there is plus 4 upon 1 plus 4 plus 9, that means be 5 upon 14. And now we will just get the probability of getting 2A naught. The probability of getting 2A naught is phi 2 psi, phi 3 psi mod psi square psi and psi. Here is you will get 0 0 1, and you have 1 2 3 mod square. You will always take mod square, and this part is 1 square, 2 square, 3 square. So that will be 9 upon 14. So you can find this answer. So you can add it. 9 upon 14, 5 upon 14 plus 9 upon 14 is 14 plus 14. So yes, it will tell about the complete basis. So always, if you have degenerate eigenvalue, you will sum it off all the probability. So this is something called the degenerate value. So this is very exciting. If you have any doubt, you can just ask me. Okay, so let's try to go for a final problem, and then we will discuss the next level of thing. Okay, are you getting this thing? Can I rub it or erase it?
Wait, sir. 2 minutes.
Wait, yes. It's okay?
Yes, sir. Now you erase it.
Okay. Okay. The any state psi is given as phi 1 plus phi 2. So you can write phi 1 and phi 2. These are the state. And Hamiltonian is given as h phi 1. H is Hamiltonian. Okay. So H is Hamiltonian. H is Hamiltonian. So what you have? So Hamiltonian is given as h phi 1 as E naught phi 1, h phi 2 as minus E naught phi 2. H phi 1 is phi 1, E naught phi 1, h phi 2 is minus E naught phi 2. Now, and this is at t is equal to 0. If h will measured, state psi at time t is equal to t, if h will measured state psi on time t is equal to t, what will measurement with what probability? So this is the first question. Second question is, after what time t psi t is orthogonal to psi 0. Psi t is orthogonal to psi 0. After what time t psi t is orthogonal to psi 0. And you have to also calculate what will be delta t. And we will just calculate later. So you have to just talk about what will be measurement on state psi at time t. So first you have to just go for the time evolution. You have to just go for the time evolution, and yes, it is given phi m is equal to delta nm. Don't worry. So this is at time t is equal to t. We have to write the time after time t. So psi t will be written as something phi 1 e to the power minus I e naught t upon h cut. So this is from the postulates 5, and phi 2 e to the power minus I minus e naught t upon h cut. And so the psi t is basically phi 1 e to the power minus I e naught t upon h cut plus phi 2 e to the power I e naught t upon h cut. So this is your new state after time t according to postulate 5. Now we will going to apply what will measurement. So obviously measurement is eigenvalue associated to either phi 1 or phi 2. This psi is written in basis of phi 1 and phi 2. So what is measurement? Measurement is E naught or minus E naught. So what is probability of getting E naught? Probability of getting E naught is equal to phi 1 psi mod psi square psi psi. So you can just get this particular thing. So now I have deliberately taken this number as 1 and 1 because the calculation will be easy. Otherwise, this can be any number. So up to that, I think you are comfortable. And then we can just calculate this particular thing. So you can get phi 1 psi. So you can get phi 1 psi t this actually. So this will get phi 1 psi t. So if I will operate phi 1 from this side, this term will survive. This term is going to 0. So what you will get? You will get phi 1 e to the power minus I e naught t upon h cat mod square by, in the denominator, psi and psi. So obviously you will take phi 1 and phi 1 will there, and this will be there. The mod of this will be 1. The mod of this will be also 1. You can easily calculate this thing because the magnitude of this number is 1. The magnitude of this number is 1. So you can have 1 plus 1. And this will be, and what will be the magnitude? Phi 1 is 1. What will be the magnitude of this number? Is 1. So you have 1 by 2. So probability is all about half to getting in a phi 1 state or getting the energy E naught. Similarly, you can get the probability of getting minus E naught. You can get probability of getting minus E naught is all about phi 2 psi mod psi square psi psi. So what you will get? You will get e to the power, and this will be something phi 2 e to the power I e naught t upon h cat upon, you can just go for psi and psi, you will take the mod square. Again, this value is half. So what will be probability? The probability of getting E naught or minus E naught is half. You can easily find. So this is very interesting. And now let's try to go for the next part. Are you comfortable up to this? Then we will go for the next part.
Sir?
Hmm.
Sir, if we find the probability in the psi 0 state also, we will get the same result.
Same result, yes. So what is the problem? There is not
So
any
that is
problem.
what- Sir, the
There is
probability
not-
will remain same with time. Is it
No,
always the
only
case?
for the energy. Only for the energy.
Okay, sir. Okay.
Only for the energy. For other thing, it is not necessary. Okay. Now, what you have to do? You have to find what will be state when psi t is orthogonal to psi 0. You have to find psi 0, psi t is equal to what? 0. So this is the thing. So obviously, in the last class, I have calculated what will be this value? That will be h cat something e2 minus e1 cos inverse, let's say, or you can write cn minus cm, cn upon cm. Remember the formula? So you can easily apply this formula. I can want en is equal to e naught, em is equal to minus e naught. So this will be h cut upon 2 e naught cos inverse. And what will be mod cn square? This will be 1, isn't it? 1 is 1, another is also 1. So what is cos inverse 1 is pi. So you have pi h cat upon 2 e naught. This is the answer. And now I am just twisting this question and giving you homework. I will just do this question in the next class. So take the homework. So what will be the homework? And this is
Excuse
very
me, sir.
interesting. Yes.
Sir, the value of cos pi is -1.
Value of cos pi.
Cos pi
Sorry, cos 1 is,
-1.
sorry, cos 1 is, so cos 1 is what? 2 pi. So this will be 2 pi, isn't it?
Sorry,
Sorry, minus sign is also there. Sorry, minus sign
minus
is also
sign is
there.
there.
Minus sign is. Sorry. There is minus sign is also there.
आएगा pi.
So that will be pi h cut upon 2 e naught. Okay. Please use the formula, this one. Yesterday I have done this formula.
Okay, sir.
Okay. So this will
Yes,
be
sir.
pi. Now take this challenge and I will do this problem tomorrow. If psi t is equal to this one, and again I have h phi 1 is equal to e naught phi 1 and h phi 2 is equal to minus e naught phi 1. Sorry, phi 2. What will be probability? What will probability that psi t will in state psi 0? This is your challenge. So what you have to calculate? I will do it tomorrow. But what you have to calculate? What will be probability that psi t will be in the state of psi 0? So you have to calculate probability that your state will be in psi t is equal to psi t psi 0 mod square, and that will be psi 0 psi 0, isn't it? What will be probability that psi t will be in the state psi 0? So what you have to do, you have to first find the psi t, and then you have to calculate this particular thing, and this will tell you how psi t will be in the state of psi 0, and you will find that will be function of time. You will find that will be function of time. So I am giving you this particular thing as a homework. I will discuss it tomorrow, and then we will go for first analysis of a free particle. So tomorrow we will just try to understand what is free particle in quantum mechanics and how we can analyze the free particles. Okay, and just you can revise each and everything. So everything will come again and again. Don't worry, and you have to apply all these things. So after the tomorrow's class, I will give you one write-up of postulates of quantum mechanics. So you can just read that write-up, and I will take one small session for the doubt of that particular write-up, only from this particular write-up. Okay, so this is mainly for you people. So we will just go for the doubt of this particular thing. Okay, so let's so this is all about the finishing of this postulates of quantum mechanics. If you have any doubt, you can very quickly just tell me.
सर सर इस प्रॉब्लम में जाई टी चेंज होके जाई 0 बनेगा ना, तो जाई 0 पहले नहीं आएगा?
नहीं, psi t will be in the state of xi 0. Xi 0 तो है ही. मैं इसकी प्रोबेबिलिटी निकाल रहा हूं इस स्टेट में होने की. हम क्या निकालते हैं? जैसे ये अगर कहते हो phi 1 psi psi, इसका मतलब क्या है जरा बताओ? इसका मतलब ये है psi 1 के psi में होने की क्या प्रोबेबिलिटी, यही है ना?
Yes,
हाँ
sir.
ना, में कुछ तो जवाब दो, है ना? psi 1 के psi
sir,
में होने की
yes.
क्या प्रोबेबिलिटी है, उसी तरह से psi t के psi 0 में होने की क्या प्रोबेबिलिटी है. एंड दोनों तरीके से मेरे हिसाब से आंसर तो सेम ही आएगा, बट दिस इज द करेक्ट एक्सप्रेशन फ्रॉम एनालॉजी. ओके
ओके सर.
ओके, सो ओके, थैंक यू. सो आप प्लीज रिवाइज
Sir.
कर लेना. हाँ, कुछ और है?
Sir, you can't provide the assignment till to up to these lectures.
आप अभी आराम से रहो ना, सब चीज समय पर मिलेगा. ओके, डोंट वरी. Once assignment will start, you will be bored of the assignment. Okay. Lot of assignments are in quantum mechanics. अभी quantum mechanics
sir.
शुरू कहाँ किए हैं? हाँ बताइए.
सर जो मेजरेबल स्टेट है साइज, सर वो इमेजिनरी भी हो सकता है ना सर?
बिल्कुल हो सकता है, बिल्कुल हो सकता है.
तो सर जब प्रोबेबिलिटी निकालेंगे तो उसमें सर अगर नेगेटिव
ये
आएगा
मॉड
तो
साइज स्क्वायर है, मॉड साइज स्क्वायर है, नेगेटिव नहीं आएगा.
अच्छा, और नीचे सर जो साइज.
नीचे भी होगा, नीचे भी नहीं आएगा, नहीं आएगा, नहीं आएगा.
ओके सर, ओके थैंक यू.
कभी नहीं आएगा. ऐसा इस तरह से पोस्टुलेट्स बनाया हुआ है कि ये सब नहीं होगी. ठीक
ओके
है, आप कैलकुलेट करना. अगर आ रहा है तो फिर कहीं मैथमेटिकल कैलकुलेशन में गड़बड़ है हमारी या आपकी. ठीक है, ओके.
ठीक है सर, थैंक यू.
ओके, चलो, थैंक यू.
Thank you, sir.